Good morning, dear students. In this class, we will learn about the example problems of price index number. So, continuing with the example 5, question is from the following data, construct Dorpish and Fisher's ideal index number. From the data given, we need to calculate Dorpish-Bowley's and Fisher's ideal index numbers we need to calculate. In the previous class, we have learnt about the formulas how to calculate Dorpish-Bowley's price index and Fisher's price index. So, coming to the question, let us see the question. Items are given, price per unit is given, total expenditure is given. Base year they have mentioned. In the current year also price and total expenditure is mentioned. But our formula is in terms of the price and the quantities. Here quantity is not mentioned. Instead of that, total expenditure is given. So we have the formula connecting between expenditure, price and quantity. That is expenditure which is equal to price into quantity. So we need to calculate first the quantity. Quantity need to be calculated by applying this formula of the base year as well as of the current year. So we need to calculate the quantities of the base year as well as the quantity of the current years. So moving on to the solution part. See here. Same way, base year price is nothing but we denote it as a price is denoted as a P naught, and this is expenditure. We need to convert it into quantities now. Here current year price will be in terms of P1. See, it has been written. That is P naught is written. Expenditure P naught Q naught will represent the expenditure, but we don't need that expenditure, whereas we need to calculate Q naught by applying P naught and P naught Q naught. So formula is given to calculate Q naught, that is Q naught is equal to P naught into Q naught divided by P naught. Next P1 is given of the current year and P1 Q1 is given, that is expenditure of the current year is given. We need to calculate Q1. After calculating Q1, first calculate P0 into Q1 and P1 into Q0. These two things if you do, then easily we can calculate the Dorpish-Bowley's price index number. These two things we need to do, then easily we can calculate a Dorpish-Bowley's price index number. So how this solution is done? Let us see to the formula. It is PB is equal to PB01, which is equal to half of P1 Q0 divided by P0 Q0 plus sigma P1 Q1 P0 Q1 into 100. So P1 Q0 we have found already, it is 241. P0 Q0 it is 108. All the total values which is there we need to calculate. All the total values, that is sum. See, this is your P0 Q0, this is your P1 Q1, this is 93 is your total of P0 Q1, and this is of P1 Q0. So substituting in the formula you get Dorpish-Bowley's price index is 218. Next, going on to the Fisher's ideal index, it is PF, which is equal to square root of P1 Q0 divided by P0 Q0 into summation of P1 Q1 into P0 Q1. Here put a bracket. First we need to solve within the square root. First solve within the square root, then you multiply it with 100. So first solve within the square root, then multiply by 100, you will get the answer, that is 217.96. Next, going on to the example 6, that is compute Kelly's price index number for 2005 from the following data. We need to calculate Kelly's price index number. So Kelly's price index number formula is P01 to the power k is equal to sigma P1 into Q divided by sigma P0 into Q into 100. So see here, commodity is given, price is given, that is of the base year as well as the current year. Previous year is called as the base year, 2000 is the base year and 2005 is the current year. Now quantity is given only one. There is no separate quantities for the base year. There is no separate quantity for the current year. Here quantity is given only one. That means here quantity neither relates the base year nor it relates the current year. So the approximate index number can be found by applying Kelly's fixed weight method. How to calculate this? Let us see the solution. That is, commodity ABCD is given. P0 is the price of the base year, P1 is the price of the current year, and Q is the quantity, which is the approximate quantity of both the years. We need to find this. For the formula we require is P0 into Q and P1 into Q. So P0 into Q is found, P1 into Q. Add this, you will get sigma P0 into Q, which is equal to 587.5, and sigma P1 into Q, which is equal to 881. Next, substitute to the Kelly's price index number, which is P01 to the power k, which is equal to sigma P1 into Q divided by sigma P0 into Q into 100, which is equal to 149.96, which is equal to 149.96. Next, compute an index number by using the following data. Compute index number by using the following data. Here it is given commodity, base year quantity is given. Base year quantity is given. Base year price is given and price of the current year is given. But quantity of the base year, quantity of the current year is not given. Going to the solution now. See there, here quantities of the base year, Q0 alone are given. You can see here base year quantities are only mentioned, that means it is Q0, and base year price is mentioned. But for the current year, price is there but no quantity. So we construct only last price index number. Why we construct last price index number is we should know only P0 Q0 and only P1 Q0. These two things if we find, we can calculate a last price index number. So we go for the last price index number. Only two quantities are needed, that is P0 Q0 and P1 Q0. We can't apply other formulas since quantity of the current year is not given. We can't go for purchase index number and further other methods. So we can only apply last price index number. So we will go for the tabulation now. Commodity ABCDE, it is given. Base year quantity is given, base year price is given, only current year price is given. So calculate P0 into Q0 and P1 into Q0. So multiply first, then add, it will give you sigma summation of P0 into Q0, which is equal to 1890, and add again sigma P1 into Q0, which will give you 2830. Now substituting these in the last price index number, so we will get formula is PL01, which is equal to sigma P1 Q naught divided by sigma P naught into Q naught into 100. So substitute, the value of P1 Q naught is 2830 and the value of P naught Q naught is 1890 into 100, which is equal to 149.74. Next, moving on to the example 8. Using the following data, calculate approximate price index numbers for the following years 2010, 2011 with regard to the base year 2005. Now base year is given, it is 2005. We need to calculate the price index for 2010 and 2011. Now let us see what are the data given. They have given the commodity, that is rice, wheat, sugar and dal. Price is given of 2005, 2010 and 2011. So they have given P0, P1 and P2. We can take this. Next, they have given the quantity units of 2005. That means they have given only the quantity of the base year. So here only quantity of the base year is only known. So we can apply only Laspeyres formula, because Laspeyres formula, that is summation of P1 Q naught divided by P0 Q naught into 100. We can't apply Pasteuris because we don't have the quantity Q1, so we are not able to apply with the Pasteuris and other price index numbers. So we need to go only with the Laspeyres price index number. So we shall see here solution. Here 2005 is the base year, 2010 and 2011 are the two current years. Since base year quantities alone are given, so Laspeyres index number are calculated. Only the base year quantities is given, so we are going to calculate only the Laspeyres index numbers only we are going to calculate. Moving on to the tabulation now, we will find that the commodity rice, wheat, sugar, dal, P0, it is nothing but the price of the base year. P1 is the price of the current year, that is 2010, and P2 is the price of the current year, that is 2011. So here two current years are there, that is P1 and P2. They have given the quantity of the base year, Q0 it is represented. So to apply the Laspeyres price index, now two formulas will be there. That is P Laspeyres price index, which is equal to sigma P1 Q0 divided by P0 Q0 into 100. And for the price index of P2, we can find Laspeyres price index as sigma P2 Q0 divided by P0 Q0. So first calculate P0 Q0, P1 Q0 and P2 Q0. So add the total, multiply and add the total, you will get 310, 466 and 608. So the Laspeyres price index for the 2010 with respect to the base year 2005 is given as PL, that is Laspeyres index P01, which is equal to sigma P1 Q0 divided by sigma P0 Q0 into 100, which is equal to 466 divided by 310 into 100, which is equal to P Laspeyres, which is equal to 150.32. Next, calculating the Laspeyres price index number for the year 2011 with respect to the base year 2005, it is given as, now the formula will change to 02. Why? Because we are going to find the Laspeyres price index for P2. So formula will become sigma P2 into Q0 divided by sigma P0 into Q0 into 100, which is equal to 608 divided by 310 into 100, which is equal to 196.13, which is equal to 196.13. Next, problem number 9. Given sigma p naught q naught which is equal to 400, sigma p1 q naught which is equal to 300. Construct a suitable index and a comment. So they have given p1 q naught and p naught q naught. So we can only find here Laspeyres price index. In the previous formulas we have seen, that is Laspeyres, it is a P01 to the power L, which is equal to sigma P1 into Q naught divided by sigma P naught Q naught. That is our formula. Since, see here the solution now, since sigma P0 Q0 and sigma P1 Q naught are given, we are given with sigma P0 Q0 and sigma P1 Q0 is given. So we compute Laspeyres price index. So we are going to calculate Laspeyres price index. How we are going to calculate? By seeing that they have given only the value of P0 Q0 and P1 Q0, and these are the terms of the Laspeyres price index. These both are the terms of the Laspeyres price index. So the formula, apply the formula, that is P01 which is equal to sigma P1 Q0 divided by sigma P0 into Q0 into 100, which is equal to 300 divided by 400 into 100, which is equal to 75, which is equal to 70. We need to comment now. So what is the comment here? So thus the level of prices in the current year is decreased by 25% as compared to the base year, because we compare to the base year has 100%. So when we compare, it is now 75. So for the comparing to the current year, the base index is decreased by 25%. Base index is decreased by 25%. Next, moving on to the example 10. That is given sigma P1 Q1 which is equal to 1500, sigma P0 Q1 which is equal to 1300. Construct a suitable index number. Sigma P1 Q1 which is equal to 500, sigma P0 Q1 which is equal to 1300. We need to construct a suitable index number. So which will suit for this index number? See here, sigma P1 Q1 and sigma P0 Q1. These are the terms of the purchase price index. So these are the terms of the purchase price index. So going to the solution now, since sigma P1 Q1, sigma P1 Q1 and sigma P0 Q0, in the question sigma P0 Q0 are given, values of both the terms are given. So we will compute purchase index. We will compute purchase index. So what is the formula for purchase index? It is P01 to the power P, which is equal to sigma P1 Q1 divided by sigma P0 Q1, which is equal to sigma P0 Q1 into 100. So purchase formula is P01 to the power P, which is equal to sigma P1 Q1 divided by sigma P0 into Q1 into 100. So next we will see the substituting. We get, that is 1500 divided by 1300 into 100, which is equal to 115.38, which is equal to 115.38. Next is example 11. Example 11. If Laspeyres index number is 150 and purchase index number is 144.6, find Dorbish, Bowley's and Fisher's index number. They have given Laspeyres index and they have given purchase index. So we need to calculate Dorbish, Bowley's and Fisher's index number. So first write the given thing. We'll directly move on to the solution. Given P01 to the power L which is equal to 150.3, P01 to the power P which is equal to 144.6. This is Las this is past cheese. So take down the formula, that is Darvish-Bowley's price index 01, which is equal to half of Las price index plus past cheese price index. So we have given Las price index is 150.3 and past cheese price index is 144.6. So substituting, we will get Darvish-Bowley's price index, which is equal to 147.45. Next, calculating the Fisher index number. Fisher index number formula is P(F01), which is equal to square root of P01 to the power L into P01 to the power P. That is a square root of Las index into past cheese index, which is equal to, multiply these both, you will get a Fisher's price index. We will get a Fisher's price index, which is equal to 147.42, which is equal to 147.42. Next, moving on to the example 12, that is, if PL, which is equal to 220.6 and PDB, which is equal to 228.4, then find PP. So here they have given Las index, which is 220.6. They have given Darvish-Bowley's price index, which is 228.4. We need to calculate a past cheese price index. So what is the relationship between Las Darvish-Bowley and past cheese? It is given here. We know that solution. We know that price index of Darvish-Bowley, which is equal to half of Las plus past cheese, which is equal to, substitute now, that is PDB is equal to 228.4, which is equal to half of 220.6 plus P to the power P, which is equal to 468, because multiply this 2 to the other side. First you take 2 to the other side, it will become 456.8, which is equal to 220.6 plus past cheese price index. So now past cheese price index you keep as it is at one place, shift 220 to other side, it will change its sign. So it will become past cheese price index is equal to 456.8 minus 220, which is equal to 236.2. Therefore, past cheese price index is 236.2. Next, moving on to the example 13. If past cheese price index 101.6 and Fisher's price index is 99.6, then find Las price index. They have given past cheese, which is 101.6. Past cheese, Fisher's, it is 99.6. You need to calculate Las price index. So given that, first write the given thing. It is a past cheese price index, it is 101.6. Fisher's price index, it is 99.6. Apply the formula. We know that Fisher's price index, which is equal to square root of Las price index into past cheese price index. So substitute it. You will get 99.6 into square root of Las price index into past cheese price index. See now here, dear students, there is a square root and within the square root there is one unknown term. So first we need to remove this square root first. How to remove this square root? So the next step will be, next is to remove the square root, we are going to square on both sides, that is squaring on both sides. So square on both sides, it is 99.6 the whole square, which is equal to square root of the whole square, it will be, which is cancelled and directly written as Las into 101.6. So keep Las as it is and shift 101.6 to the other side, it will go to the denominator. So next step will be Las is equal to 99.6 the whole square divided by 101.6, which is equal to 97.64. Therefore, last period's price index is 97.64. Moving on to the next problem. Example 14. Calculate the price index number by weighted average of price relatives method using arithmetic mean. Calculate price index numbers by weighted average price relative method using arithmetic mean. First, let us see what they have given first. They have given commodities, that is wheat, rice, gram and pulses. Price they have given 2005 and 2010. So 2005 is our base year, 2010 is our current year. They have given the weights which neither relates to both base year and the current year. So what is the formula first? Formula is a price index which is equal to sigma WP. Sigma WP divided by sigma W. So first we need to calculate P. First we need to calculate P, then W into P. So substitute commodities wheat, rice, gram and pulses. 2005 I will take it as the base year. P1 has the current year. 2010 has the current year, P1. And W are the weights which is given 4321. Next we need to calculate P. So how will you calculate P? Formula is given within the tabular column, that is P1 divided by P0 into 100. P is equal to P1 divided by P0 into 100. That is given here. Next W into P. Once if we calculate P, then multiply W and this column W into P, which will give you W into P, which is equal to 533.32, 412.5, 320, 200. Next add all this, which will give you sigma WP, which is equal to 1465.82. Next final, that is price index by weighted average of price relative method using arithmetic mean is P01, which is equal to sigma WP divided by sigma W, which is equal to 1465.82 divided by 10, which is equal to 146.58, which is equal to 146.58. Next, example 15, that is calculate weighted geometric mean price index from the following data. We need to calculate weighted geometric mean of a price index. Items are given A, B, C, D, E. Expenses in percentage it is given, that is 30, 15, 20, 10 and 25. Price is given, base year they have given and the current year they have given. Now we shall see the solution. So next solution, items they have given A, B, C, D, E. Weights they have given, that is 30, 15, 20, 10 and 25. Base year price, current year price they have given. First you need to calculate P. You know the formula, that is P is equal to P1 divided by P0 into 100. Calculate P. Then logarithm of P. In the calculate, use the logarithmic function and apply. You will get logarithm of 90 is 1.94. Logarithm of 100 is 2. Logarithm of 85.7 is 1.933. Logarithm of 75 is 1.875. Logarithm of 137.5 is 2.138. Next, multiply this weights W into log P. W into log P will get these values. Then add all this, you will get sigma W into log P, which is equal to 199.494. Next, the formula for the weighted geometric mean index number. The formula for the weighted geometric mean index number, that is P01, which is equal to anti-logarithm of sigma W log P divided by sigma W, which is equal to anti-logarithm of first solve within the bracket, then apply at the last anti-logarithm in your calculator and get the answer, that is P01 is equal to 98.33. 98.83. So dear students, I'll wind up today's class here. Exercise problems of the textbook and example problems as well as the practical problems kindly take down in your notebooks and solve them. Thank you.